Invisible quantum waves, how shape-shifting supermaterials are born. What do deep-sea sponges and the future of computing have in common? More than you might think. For the first time ever, scientists have watched quantum energy waves in action as they formed shape-shifting nanomaterials in real time. This isn't just cutting-edge science. It's the key to creating a whole new class of reconfigurable supermaterials. These materials could revolutionize everything, from shock-absorbing gear to adaptive robots, to computers that move sound and light like electricity. It all starts with a strange but powerful phenomenon: phonons. Think of phonons as tiny, invisible energy packets rippling through atoms, particles, or even 3D printed hinges. They carry heat, they guide sound, and in the right material, they can shape how that material behaves. Nature already uses phonons brilliantly. Take the skeletons of deep-sea sponges, lightweight yet strong enough to survive crushing ocean pressure, or earthquake-resistant materials that redirect seismic energy. Now, for the first time, researchers at the University of Illinois used liquid-phase electron microscopy to watch phonon waves in action, while nanomaterials assembled themselves live. This is the first time we've observed phonon dynamics inside nanoparticle self-assemblies, says Professor Chien Chen. These structures act like mechanical metamaterials, custom-built for performance. That means these materials can now be designed to adapt, changing shape, stiffness, or energy response depending on the situation. We're talking about materials that think, and there's more. The team used machine learning to trace how particles self-organize, mapping their hidden pathways using data-driven models. This opens the door to AI-guided design, says researcher Pan. We can now predict and even control how these materials build themselves. The possibilities are wild. Programmable shock absorbers, morphing drones, and computing components that steer sound and light with quantum precision. This is more than just innovation. It's the birth of a new era of smart matter. The project was supported by the Office of Naval Research, the National Science Foundation, and the Army Research Office, pushing the boundaries of what materials can do. When invisible quantum waves build matter, our world won't just react to energy, it will reshape itself with it. If this blew your mind, give us a thumbs up. Subscribe for more science-powered stories. And don't forget to hit that bell icon. Until next time, stay curious.